Welcome back to the Automate Construction Podcast. I'm here with Edouard Cabay, an architect from IAAC, leading the future of education in the university system for 3D printed construction, creating all kinds of new departments that are going to create the future workforces for this industry. Thank you so much for joining me today.
Thank you, Jared. Nice to be here. Very nice.
Yeah, and I was super curious about, let's start at the origins of 3D printed construction at IAAC. Do you know when they first started participating? To dedicate a whole department is obviously a big commitment. How did they get to that point?
Absolutely. So the school is relatively young. The institute is about 25 years old. It was created here a little bit, with the belief of all these new technologies coming up. What can we do with it in the field of construction, the field of architecture, and the field of urbanism? So from very early on, we started to work with technology. We started to work with open source technology, and to look at robots, right? And also to start to really work with them ourselves, both educators and the students. So the question of 3D printing very quickly came in a very experimental manner, no? Playing with different materials. At the same time, we were one of the institutes in Europe to first have a fab lab, no? So to have the connection with MIT. So it's been a school that is very hands-on from the beginning.
Were you
More
there?
and more. I started 11 years ago, actually. So I'm a little bit more recent than that.
So they
Correct.
were doing 3D printed construction before you got there 11 years ago.
Absolutely. Yeah. I think
Wow.
I couldn't give you a date, but it's been at least 15 years or 20 years that we look at 3D printing in the architectural academia. Correct.
That's a lot more years than I'm used to hearing people talk about on this podcast.
Mm. Sure. No, it's been a long time, and the program that I now co-direct, which is exclusively focusing on 3D printing, and it's exclusively focusing on 3D printing with the soil or with earth. That has been now 9 years that we are running this program, and of course, this didn't come out of nowhere. This came out from a series of projects that we had been working on, where we had the intuition or the understanding maybe that this is a technique that is very important in the future of construction, and then of course also in design, right?
Yeah, we agree there for sure. And so the university started doing some experiments in printing, and then how long ago was it that they started the department dedicated to?
It was nine
There's two.
9 years ago.
Okay, 9 years ago. So that dedicated to Adobe, and is there a separate project for
Correct.
concrete or only Adobe? Yeah, okay. So
Yeah,
two
so
different
that
departments.
at that moment, we had been doing 3D printing projects with different types of materials, and Earth was for us a very interesting one because we were able to make a prototype, break it, and then print another prototype with it. No, so this idea of circularity was there already from the kind of lab phase, just on a very pragmatic level to see, okay, how can we recycle our material? And we decided 9 years ago to set up this program, and we started to work with a group at that time, quite a small group of students, and literally, rapid prototyping with the material from day one with the students. Um, what I think maybe was interesting in the beginning of the program, so first of all, we had few students because that technology was still yet not, let's say, promised to this beautiful future as it is being done now. No, at that time we had to really had some very strong vision. It could go, it
Absolutely.
could, or it might not, but at least we wanted to try. So that means that, of course, it was a bit less attractive for students at that time because there was not a clear career in that. No, now things have changed very, very, very radically. And the other thing that was interesting in the beginning is that, and maybe we talk more about this, but when you have to design, because at the end of the day, we work a lot with technology, but we are architects, so we are designers, and we are very interested in how to design with this technology. The first years of the program, we didn't have really a clear methodology on how to design. No, we say, okay, we have full freedom, or we have a huge amount of freedom, and it was actually very difficult to draw or to model or to print anything that makes sense. No, we were printing a lot of different shapes, and we were going in all sorts of directions. And the first years for me were difficult because it was hard to think that we were printing things that were relevant, no, that were really taking advantage of this technology and producing results that were better for whatever question we were targeting. So the beginning was fun, difficult, but fun. And I'm happy that now we've been doing this for 9 years because we start to, really understand how to work with this now.
Yeah, I mean, when it's completely new territory, it's very hard to figure out. You're kind of going all unknown directions, and so figuring out where you are, you
Absolutely.
have to throw a lot of spaghetti at the wall. Uh,
Completely. And what we teach our students is that we don't go into an extensive history of architecture, but we like to look at history of architecture in relation to the techniques or the materials that came. No? So we like to look at Gothic cathedral in relationship to the geometry of the arched vault. We like to look at the fact that skyscrapers came the moment that steel really started to have a breakthrough in construction. And there's many other examples. So now, if we think of an architecture that is 3D printed with a technology that is so different from all the ones before, even if we can set up some parallelism, with kind of bricklaying, for example, there are some of these relationships, but essentially the technique is very new. So if the technique is so new, what is this new architecture that is going to emerge out of it? No, that is, I think, for us, this is one of the main questions we are exploring. And we see tons of people within the world that are playing with this. Um, I'm still I'm still curious. I still think we have plenty to discover and really a kind of new architecture to needs to emerge out of this beautiful new technology.
I mean, what a beautiful thing that robots and technology would circle us back to one of the most primitive building materials we've ever used. Uh, the I think Adobe is very promising too. There seems to be some really cool groups focused on that.
Yeah,
There's a lot of
there
problems with printed concrete, like the cement concentration. So people wonder about how to reduce the cement. Adobe reduces it entirely.
absolutely, absolutely. There's when it comes to Earth, um, it's a very interesting materials for many reasons. I mean, the kind of bottom line is that it's a material that is there. So we've constructed, not kilometer zero. We've constructed with materials 5 meters away from the thing we actually made. No, so it's kilometer zero for us seems very big. No, we've reduced this to 5 meters, which is a possibility potential of that. So that means no transport. It means a huge saving of energy. Then afterwards, we take the earth straight from the ground, we dry it, we sieve it, and then we add some natural fibers to it and we print. So that means that the material does not need, like others, concrete, for example, to go through a process system to convert a raw material into a building material, which in the case of concrete requires being heated to 1200 degrees for a certain amount of time. So that means that the material doesn't need embedded energy in order to become a building material. And then that also means, of course, that the material that we build with remains natural. It's absolutely non-contaminant, uh, which is very interesting. So that means we can do building solutions that are incredibly efficient from an energy point of view and from a recyclability point of view. No?
It
Now,
checks
of
all the
course,
boxes.
it checks a lot. I think there's something. I think it's such a good material for construction, not just for 3D printing, right? For many other techniques.
But
I think it's a
we're
material
not
that
doing
is
this
coming back.
podcast in Adobe Homes. Like you're not doing
Sorry,
this from
once
an
again.
Adobe home. We're not doing this podcast from Adobe Homes yet, so there's something in the way.
Yeah, correct. No, and it's beautiful, no, that many people work with this technology.
Yeah.
It's what I find interesting is that it's a pre-industrial material, right? It has been used for thousands of years throughout the world, not just in warm and dry climates. In where I'm from in Belgium, earth was a common construction technique. Where you are from, it was basically all over the world in all types of climates. But somehow, with the arrival of reinforced concrete and other techniques then that are more performative from a mechanical point of view, um, earth became less of an interesting material. Um, Today, that we are looking at the energy balance, of course, suddenly earth is coming back. But what is beautiful is since it was more or less dropped, 150 years ago, at least for mainstream construction, it means that the evolution of earth construction stopped at a moment where buildings were not yet made by machines. Buildings were not yet retrofitted with air conditioning systems, which means that they are full of passive energy strategies. No, they're actually incredibly interesting construction systems for an architecture that is incredibly efficient from an energy point of view. No, and all of this heritage throughout the world is we have not paid any attention to it until, I mean, some people have, but very few, let's say. So until a decade ago, like this was almost kind of falling into ready to be forgotten. And suddenly now the fact that some people work with 3D printing and also many others that work without are going to look at all of these pieces of architecture, vernacular architecture throughout the world, and are composing an incredibly strong library of techniques that are ready to be used and to provide solutions to super contemporary problems, no? The ones of energy, the ones of construction, and many others. So I like this kind of strange thing that a new technology is like very much sending us to the past to say, go and get the heritage and value that heritage because it is so useful at the moment.
Yeah, without that, it was becoming obscure. And the geometry, like you mentioned, of the walls, like the Tekla house, if I'm correct, the air you were saying is like forcibly pushed through there in ways that's beneficial for the insulation, or how does that work?
Correct. So when friends or people ask me about about the potential of 3D printing, I think there's many, and this is something that you're really beautifully exploring. As a designer, what I find very interesting is that we create cavities, right? So earth architecture and concrete architecture before 3D printing is mostly relying on formwork, no? So make the form and then fill it up fully, and then of course, there are some systems about embedding some other, whether it's balloons or styrofoam or tubes or whatever. These are techniques that exist, but essentially, you use the material very fluid, and you fill up a hole or a volume. No, with 3D printing, the fact that you only need to you only put material wherever you need and create these cavities means that afterwards these cavities are really useful for services, for example. And in our case, of course, we like to look at them from a climatic point of view. So we can fill them up with mass, we can fill them up with insulation, depending on, on the orientation or on the climate, the location. But we can also fill them with cavity that can ventilate themselves, right? So we've been working a lot with this idea of how to do certain perforations in a wall and create some of the layers of our 3D printed walls that are full cavities, and that therefore, can really, if you make an analysis of the fluids of the wind around a building, you can find the areas where you have low pressure and high pressure and do perforations here, perforations there, and then make sure that there is a continuous cavity in between them, which means that the entire of the kind of inside of your walls get constantly ventilated, which can be really useful from a thermal point of view, right? If it's a hot climate and the building needs to be cooled down, this is a technique. And again, this is not a technique that we have been inventing. This is something that has been around for forever. And we really like to go and look at all types of building. So for me, it's
Sounds
an
like something a
amazing.
computer could optimize.
Sorry.
It sounds like something a computer could easily optimize if it knows the calculation, figure out the high pressure, the low pressure, where the hole goes.
Absolutely.
The machine could potentially do all that itself.
Yeah. For me, it's interesting because, like they are like kind of our ancestors that were doing this all their life with a lot of culture, and they knew this without needing to calculate, right?
Mhm.
But these were specialized, super specialized people. There are still a few around, but there's not many.
We're
I
too
think as
stupid now.
designers, I don't know. We I think we're much more maybe transversal, and we are much less dedicated to one thing. We are managing a robot, playing with the material, designing,
I'm
and I
only
think
kidding. We
what
went
is
on
it?
a different skill tree.
So yeah, absolutely, absolutely. But what I find, of course, great is you're right. I think um, uh, computational thinking or computational work can enable us to really understand how these phenomena work, no? And they can help us to design with them. It's just as a small parenthesis, it's very hard, it's very easy to get them wrong, no? It's very easy to use these digital technologies and then to end up to results that look incredibly sophisticated and incredibly well, and then at the end, we made a mistake in the parameter, and all of this creates a wrong result. So I think it's really important to kind of work very carefully with these tools, but with digital technology, especially in design and computer science, we can make things that, of course, we could not be able to calculate without the digital world. No? And for us, we're very excited about 3D printing because it is actually a computer. It's a technology that rests on a computer. So all of the software and all of the intelligence can go into construction, right?
Yeah, that makes a lot of sense. Using people for their minds instead of the physical labor so much. Maybe it even
Yeah,
improves the jobs for the people who are on site. Uh,
absolutely,
how,
absolutely.
as an architect, how do you make the building compelling for someone to live in, considering it's built of mud?
Yeah, that's a good question because true, it is made of mud, it is made of earth, it is, of course, it takes the color of the soil that is next to it, which is something that we are absolutely not used to in our contemporary culture. It used to be like that, and I think, if you go to certain geographies, there's incredibly beautiful pieces of architecture that really belong to the landscape, no? Of course, in our dense city centers, it's slightly odd to have that. No, so for me, what's and we've completed Tova, this small little house here in the natural park in Barcelona, and so the inside of this, it's a room that is 3 by 3 meters. Sorry, I'm not sure what this makes in feet.
That's fine. Meters are
Maybe
great.
Meters are great, fantastic. The inside is dark, right? And at the moment, we are going through the work of understanding what is the natural plaster we want to use to be able to make the inside very domestic. So in this case, I really like the fact that the outer, the outer envelope is the raw printing. We apply, of course, some organic, they're not products because we kind of make them ourselves in order to protect from the water, but then they're transparent, so the outside stays as it was printed, while the inside we like to go and finish. And I really like this difference from the inside and outside. No, from outside it looks like a piece of earth, and then from inside it's a domestic space like the one you live in, the one I live in. We don't have to live in a cave. We don't have to there's an interesting example which is in Geneva, for example, like the city that we associate with banking and with Switzerland. Um, a lot of buildings in Geneva are made from earth, but very few people know this because they have been cladded from the inside and the outside with all of these finishes. So it's
Hmm.
actually we could live in earth houses without noticing that that they're not made of concrete, of bricks, of timber, or other traditional techniques.
Yeah, that's very interesting. You get the best of both worlds in some sense that way. You mentioned you're from Belgium. Belgium is one of the best countries for architecture, in my opinion, because they have every home is different next to each other. Almost like no two houses in Belgium are the same, right?
That's true. That's true. In Belgium, everyone wants a house. The country is very flat, so it's very easy to use the landscape. There's a very long history. There's a very long history of brick. There's a very long history of architecture, and there is also a very good history of architectural design. But so there is actually a lot of work for architects, and very little architecture gets repeated, which sometimes
Mhm.
leads to things that are not as good as we would wish, but also there's a lot of quality, and that's also for sure coming from diversity. Yeah,
Yeah, it's pretty cool. I was visiting just for one day. I saw Camp C, where they printed the two-story building. Maybe I'm sure you've heard of it. Uh,
sure, absolutely.
you've probably been there.
No, I haven't. I haven't.
No.
There's something strange. We have been very much kind of in a tunnel vision, looking at 3D printing with Earth. Uh, and there are differences definitely with how to print with concrete, and I can
Totally.
extend a little bit on that. So we keep an eye on everything that is happening with concrete, but we're not going there. And I, of course, I will go to visit some places because I want to learn. And we're friends with cobots. We're friends with many people that work with concrete. But let's say we've kind of at least in our academic program and professional program, we've kind of put there a kind of limit, which at the moment we are challenging because we start to have more and more opportunities to go in different directions. So we like to print with more and more materials, and I think concrete, if well used, can be also a very good material for construction with 3D printing. But I haven't been visiting because we've been visiting earth buildings all the time to try to learn from them and to apply that back.
Very cool. Very cool. And so what's the setup you guys have for printing in your lab? Do you have one printer or is it multiple printers? Do you have robotic arm gantry systems? What's the
Yeah, so we have different scales. Um, I'll, I'll I'll maybe work from or answer, sorry, rather than work from a teaching and from a research point of view. So we have this relationship of scale. So we say that, at the kind of very small scale, we work with drawing, and sketching is important, and then digital drawing is important, drafting is important, all sorts of architecture drawing we value it a lot. And it's a good tool because with drawing you can make a lot of options very quick, no? So let's say we will make 1,000 drawings, and then from these 1,000 drawings, then we jump to a 3D printing scale, and we work at the beginning with desktop printers to be able to very quickly take some conclusions. And desktop printers, they enable us to make little clay prints that are about this size. So with these 1,000 drawings, then we print 100, let's say, small models, no?
and are the
And
physics
these are
parameters similar? So when they jump, when it since it's clay in the desktop printer, not plastic, it can do similar overhang and similar qualities that your Adobe can do, or no? Okay.
absolutely not. No, clay is very different. The behavior of the material, because it's like concrete. When it comes out of the nozzle, it's wet, so absolutely different from plastic. The question of the overhang is everything if we want to go away from walls that are straight extrusions. So yeah, no, the qualities are very different. Um, the next scale with which we work is the scale of the robotic arm, which we have inside the lab, where we have a custom-made extruder. And let's say, so with 1,000 drawings, we make 100 small prints, and then maybe we go and do 3 or 4 prototypes that are maybe the scale of the human body, that are done with a robotic arm, 1.5 meters, 2 meters maximum prints. And then from there, then we work with a really nice piece of equipment from WASP, so a company based in Italy, who are our industrial partners, and that have been pushing 3D printing with Earth in an amazing manner since many, many years.
Yeah.
And so that's a crane. So that is a machine that has a diameter of 8 meters, height of 4 meters. And with that machine, then now we can print things that are much larger. So with that, we will print the one, no? So I really like this relationship, 1,000 drawings, 100 small prints, 3 larger prototypes, and then one end product, no? And I think for me, from a design point of view, looking through design iterations, searching for what is the best building to print, it's kind of I like this. I like these numbers. Also, it states that, we have to go many times through the question before finding the best possible solution. It's a lot of work, actually.
Yeah, I agree. It's almost like the way AI would approach it in that you have when you have access to so much compute, I guess in an educational setting, you have all these students who have their minds which can compute human compute, maybe more valuable
Yeah,
than AI compute. And so you can set them all to the task, you get 1,000 models back. And so now you guys can all look at those models and maybe even they can give feedback too, pick their favorites. And yeah, it's a great feedback loop. And I
absolutely.
think AI would be similar. Like maybe AI could in a second give you an extra 1,000 to put into your consideration, and then you do a
Yeah,
blind study. Who knows if the final one you pick is done by a student or the AI? Who knows if
absolutely.
the AI could have designed it without the student's work?
Absolutely. And for me, this is super interesting. First of all, because AI is here, and we are still here. No, so I don't believe that one is going to replace another. I think that we are now living within a realm where the digital world is embedded with the physical world. And I think we need to use it in the smartest way possible. Now, what I find interesting, when we tell our students, okay, now make 100 models, they're really good at doing them. I mean, our students are incredible. They are super strong. So, but sometimes what happens, we call this catalogs. We say, okay, if you need now to develop the design, do a catalog, produce 12 options, not one, and you might be sure that the first one is the right one, but produce the 12, and you have to do 12. So at least it will make you, really think about what are all the alternatives. And then, of course, when the catalog is done, so when students come with this slide with 12 3D models that are very nicely drawn, um, Then, of course, the question is, how do you evaluate, right? How do you compare these 12 options in order to find the right one? And and we know that construction is a complex science, design is a complex science, technology is a complex science. So the conversations that happen on these sheets of 12 options are extremely interesting because they can go in all sorts of directions. No, it can be about overhang, can be about printability, but it can be about, the potential of such a solution on a floor plan level, or from a printability level, from a material level, from a quantity level, from a drying level. So there's so many ways. So then we start to have to be quite scientific with, like sometimes we literally work with Excel spreadsheets to do an evaluation analysis of 12 options we design. No? And that's where design, which is a discipline that is highly intuitive but also very systematic, also becomes scientific. No? And in the program, we cultivate this way of working that is both scientific and creative at the same time, right?
Yeah. So I'm wondering, you lead that department or co-lead the department, and are you also practicing architect on the side too, or is
Yes, I'm a practicing architect. Also, I'm also an artist because I really like these questions of design, and I have a kind of practice into drawing, which I really like to relate to 3D printing, because for me 3D printing is nothing else than drawing, except that it's three dimensionally, no? So all of these things very 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 nicely come together, and yes, I work as an architect, and as an architect, I'm really interested to understand how to bring this technology to the market, which is something that in the institute we are also doing a lot. So we not only we run an academic program, we also run quite a lot of professional projects. We have just come back from the Biennale of Venice, where we have done there a country pavilion, and so we yes, we go far beyond, let's say, the academic side of thing, and we really want to print buildings. No, that's what we want to print buildings to demonstrate to the world that 3D printing with Earth is a valid construction technology that is absolutely great for today's environment.
yeah, I think the number of Adobe homes is increasing, so more people get to experience it and judge for themselves. Uh,
Yeah, absolutely.
the students that took the beginning first classes of the department, what does that look like for a department to the first year? Uh,
Well, so we have a very nice team in which we have different people with different interests. By now, we are a little bit more organized simply because we have grown. But for sure, at the beginning, we were very hands-on, and asking our students to be very hands-on. So we had a lot. We don't make our printers. We retrofit existing printers, and we've developed our own extruders in the school. But by now, we work with quite a lot of industrial partners, mainly WASP, but we also work with others. But at the beginning, it was a bit like whoever starts his project in his garage. It was about yeah, it was about getting our hands dirty and starting to print. By now, 9 years later, we have a material expert, we have a machine expert, we have a computation expert, we have a construction expert. So we have all of these people that are framing our students and taking them to the all many uh, different steps. Um, Maybe one thing that's important for us, and is often a question, is we we are training mainly architects. Sometimes we have engineers, we have sometimes material scientists, and we really like to have this diversity. But essentially, we are an architecture course, no? And but we ask our students to prototype, and one of the last prototype we did was Tova, no? This little building. So our students make buildings in the program within this 6 month span, and it's always interesting because at the end of the program, there are some that go work in construction companies, some that go to work in architectural office, and we always have this very nice, beautiful conversation about what their next steps might be. Um, I think essentially most of the students we train, they end up being architects. Um, but if you have gone through the process of 3D printing a little house yourself, then you know how to design, right? You have gone through all of the difficulties so that when you go back to design, you know all of the mistakes to not do. Because the fact is, the this technique is so new, this technique is so particular that you cannot design anything. You have to design something intelligent because otherwise, firstly, it makes no sense to go with that technology. And then secondly, you create a lot of problems. So we are really strong believers that in order to design well, you need to be able to master the technique well. And in this case, the technique doesn't really exist yet because it's so new. So we have to invent a lot. And I like that a lot. I like to see the diversity of the directions in which our alumni go, but I like the fact that some of them that really continue into the architectural field, they become, I think in my eyes, some of the best designers there are around because they have all that knowledge, right? And that's where, for me, there is definitely an absolute need for architectural universities, architectural course in universities throughout the world to start to have their own course in 3D printing, because otherwise the market will be equipped with this incredible technology and we will still not really know what we're supposed to design with it, right? And for me, that is an absolutely urgent question and a very difficult one that we are actively trying to work on, no, provide answers.
Yeah, it's very interesting. There's the talent pool of 3D printing designers to draw from a little bit, but then there's no structural anything behind that. So it's
Of
almost like a
course.
combination. If you have like an architect teamed up with someone who designs STL files specifically, or the architects are trained. I mean, you probably train your students to design STL files or step files.
Correct. Yeah, yeah. We work with G code we produce G code from Grasshopper. So yes, I mean, and you know, we start to develop quite powerful tools that make that whenever you design a wall, not only you model it, but at the same time you have all of the production parameters, right? So
Qualify it.
so that yeah, that means that you're not designing something and then wondering how to construct it. You design something you can have the economy immediately close to you, right? And I think this is definitely something beam systems and others are exploring that. I like because we do it with kind of our custom made tool. So that is something that is also part of a very creative process. No, I don't. I'm always a little bit afraid of locking the architect in a box where the architect is just operating within extremely complex and extremely complex software in which we end up being doing drag and drop. For me, and I think for us in the program, there is a huge we are playing with this because of its creative potential, right? So we want to be able to experiment as much as possible and to bring new solutions. But I think that the design process is definitely uh, something that is new and that is different from what we were doing in the past. Absolutely, absolutely.
Yeah, you're definitely a little bit biased for this question, but let's try to take a step back and look at architects in general, because I don't get to interact with so many architects. I imagine you probably do. Uh, so do architects are architects really excited about 3D printed construction and 3D printed architecture from outside your program?
It depends. It really depends on the type of architects. You know, there are architects that really are technophile, others that are a bit technophobe. There are some that are interested in technique. I think all architects are interested in techniques, no? But some of them sometimes look at digital technology and digital manufacturing as something that is maybe not absolutely necessary or maybe is not mature enough to yet make it. And then there are many that are absolutely driven to that, no? Maybe it's also because it's hard, right? I mean, to Alex and myself who run this program, we've dedicated at least Alex his full life and me, not exactly full, but a lot of it to doing architecture through the filter of this new technology, right? Um, so I think that it's it's definitely affecting the way that we work and the way we design. And there is a lot of interest from architects. There is, I mean, more and more see that it's possible, more and more see that it's coming, more and more realize also that it's very difficult to work with from a kind of design perspective. Um, I think I don't know. Maybe from my point of view, I still feel that you know that um, how can I say it? Because I think there's already tremendous work being done from a design perspective in 3D printing. But I'm still waiting to see buildings that that look like they were not they wouldn't have been possible to make to be made with another technology, And of course, that also implies that they have to be better, or they have to have clear qualities. It cannot be just an exercise of doing something different for the sake of doing different. It's it's being able to understand what more can we do with this technology in order to make better buildings, right? I'm still waiting. I'm still waiting because I think there's so much to do, and I the more people will do this, I think the better outcomes there will be, right?
Yeah, I agree 100% on that. Uh,
Mm.
yeah. So the students that you had 9 years ago, they go and they work and they're all mostly architects. Have any of them done printed Adobe?
Yes, definitely. So I don't think any of them have set their company into the field of 3D printers. Some have set
Hmm.
companies in the world of robotic construction, so that has been happening. And then
Any
afterwards, we
companies
have
or
some
no?
students. I have to look. I forgot the name, but
Okay.
I will look at it and forward that to you. Um, we have students that are now 3D printing with concrete in India. And again, I will fall short of the name, unfortunately, but I can pass that to you.
Tvasta,
Um, sorry?
Miko or Tvasta.
No, it's not those ones. It's not those ones. But I will, yeah, I will look into it. Sorry, I know that this is a podcast, so it's probably not very useful, but
No, it's okay.
I will look into it. We have a student, an ex-student that has now become also a professor in the University of Hong Kong, and she is there leading a 3D printing department and working with clay also on an architectural scale. She's been doing coral pieces that are in the sea. So, but I think it's an interesting question because I remember the conversation 5 years ago when we would finish the program and the students asking the students what they were going to do. And 5 years ago, I can tell you that it was quite difficult for a student to find work within this field.
Yeah,
Um,
that's why
now,
I asked.
yeah, now it's very different. Now we have 20 students. We are growing probably to 25 next year. When the program finishes, they start to get quite a lot of phone calls, and there is a lot of interest for them, no, because they have a knowledge that very few have. So, and I can tell this over the years. 9 years ago, no interest from this field. 4 years ago, one or two, and now suddenly it's strong. And I expect within a few years, all our students will be hired before the end of the program, because there will be so much necessity for it, no?
Yeah, that would be great. Uh, it's been really cool. I
Mm.
mean, even I've only been doing this full time for the past 3 years, and in that time, I feel like I've watched the industry explode from maybe 10 homes to now 100 homes, and it's really it's speeding up. I mean, now you have multiple companies starting 100 home projects, so pretty soon we'll have 1,000 homes and then 10,000
Yeah,
homes. Uh,
absolutely. It's interesting again to my students. So when I give a lecture, I like to show the first reinforced concrete house that was done in the United States in 1871. And
mm,
then 40 years later, when Le Corbusier presents Casa Domino, which is actually it's essentially a construction system that is incredibly efficient and optimized for reinforced concrete, which is what has been used to produce a huge amount of the percent of the housing, infrastructure that is being made today. So between that first and the invention of a good system, there's 40 years, and that is a very long time. And I think with 3D printing is the same, even though because of today we work much faster, we have much more tools, we communicate much more, we share. Maybe much more. I expect these 40 years to be reduced to something very short, but we
mm.
still need to go through this time of development. And the more things we do, the better we will do them. No, so I'm also really looking forward to the moment we get to 1,000 house, and then 10,000. And I'm dying for a lot of these also to be made out of earth, obviously.
Yeah, I think we will see that uh, those numbers in coming decades. Hopefully one, but we'll see. Uh,
Yeah.
the earth, you mentioned there's some other materials besides concrete you're starting to explore. Can we talk about some of those?
So we've collaborated recently with CETA, a school in university in Denmark, and we've worked with them. They've worked with cellulose, so we worked on kind of encounters between clay walls and cellulose 3D printed panels. They've used them essentially to kind of work on screens in which they can work with the let's say the porosity of light. So we've worked through that. And then in the school, we have a material department. And unfortunately, I'm not so good at talking about this, so I'm not gonna extend. Um, but we work a lot with bioplastics. We work a lot, yes, with cellulose. We work a lot with earth and mixing earth with different types of materials. I was recently with some people that have horses and that produce a lot of horse dump, and so this
Okay.
is something that
Print
we're
that.
seeing how to. Uh,
You can print that.
yeah, it's full of it's good. It's fibers. It's basically processed fibers, so it's a fantastic material. And you know what? I mean, once again, these are things that our grandparents were doing, right? They mixed earth with cow dump, with horse dump, with cow blood, with all sorts of materials.
Well, that's a
And
viral video.
okay, yeah, we'll do something and share it with you. Absolutely.
House made of blood and poo.
Absolutely. And a bit of earth, hopefully, just to make sure that the smell doesn't go wrong. We've
It's all
printed with
important things.
we've put lactose in our prints, which worked well, created a horrendous smell of cheese after some days. But yeah, but all of these are, ancestral techniques that are interesting and that are of course organic, right?
You haven't tried rotten eggs yet?
We've tried eggs. I mean, we use eggs, so they're not
Try
they're
it.
not quite rotten, but yes, we use egg whites to yeah, 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 absolutely. And a lot of these things work. We used to work with a material scientist who a very interesting person. His work was to renovate arts and crafts buildings in Barcelona, so buildings that are 120, 130 years old. Um, and it was his approach to renovating them is that he was saying these buildings are libraries of pre-industrial materials, pre-oil materials. So the silicones used to be made with how do you say this in English? With the residues from the shrimp or the skin of shrimps. So
Okay.
these were being kept, and some sort of glue was being made with them, and they were used in order to frame windows. Earth was very common, rabbit glue, like all of these materials in architecture. The architecture of 130 years ago, the construction of 130 years ago, these are libraries of all of these materials that are organic materials, and this I find absolutely great for today to go and look at them and then to see, okay, what can we do with these today when if we work with digital technology, with 3D printing and other methods.
Yeah, I think it's easy to forget in the society we live that you can go out in nature and find things and make things yourself,
Sure.
not at Walmart.
Yeah, sure. I mean,
Or
it's fun, no? I think most of the people that are interested by 3D printing are people that like to do things, no? They like to make things. So they're not interested only in the kind of standardized solution. They're interested in going into things, no? Making them, designing them, make something different, make something of your own. And I think for me, of course, this connects very strongly to all of this self-construction culture, no? And I like because they used to be a little bit, like a little bit back to back, no? They were like, people that would go in the woods and make their house. They would look at the person that is playing with a computer or playing with a printer. And look, now this guy is in another world, no? And I like the fact that now, little by little, like we speak to
Mm.
each other, right? And in our team, we have people that probably 15 years ago were absolutely not interested in what we were doing, but now because they know that we are able to print with earth, they're like, okay, that's interesting. I like it. I'm not a geek. I'm a material, I'm a biomaterial, a person in love in biomaterial, but suddenly that digital equipment can help me in order to go further. No?
yeah, I guess I'm
You know,
so late to this.
Mhm.
industry that I see the companies involved, but before there were really any companies, before Icon, before Wasp, before all the 3D, before Cobod, before Seabay, universities were printing a lot, sounds like.
Yes, I think for sure a lot of companies have were born as spin-offs from university research. I think that's absolutely the case. I think also it's very interesting for companies to be close to universities, no? Because I think a lot of research needs to be done in the university level. Of course, it's much more fluent, no? I mean, researchers are there for that. So I think it's very interesting for companies to partner with universities. This is a model that is also not so old, right? I mean, 15 years ago, it was not so common for universities
Did
to do
those companies
professional
partner with
robotics.
universities?
Sorry,
Did those companies partner with universities? Or were they spun off from universities?
which ones?
I don't know. Maybe it's easier to name the ones that were.
So WASP, for example, we are partners with them, which means
Yeah,
that we
yeah.
have a kind of flow of equipment of knowledge. We have worked with I mean we've worked with a company in Spain called Tecnalia. They were not 3D printing, but they were developing or they are developing cable robots. So for example, we took our extruder and we put it, you know, this was 8 years ago. We printed with a cable with a cage that was 16 meters by 8 meters by 6 meters, and suddenly we had been on our robotic arm with a with a footprint or with a bounding box of 2 by 2 by 2, and suddenly our bounding box was the bounding box of a house, So that was terribly fun, and that was thanks to a kind of a partnership to a company. Yes, so I think for me, there is a lot of benefit from doing this. Absolutely.
Cool. And what about other types of robotics? Have you guys thought about implementing like the Spot robot from Boston Dynamics or maybe like the Tesla Optimus bot or the Palm E or something, Atlas?
Not yet, and I hope that we will. It feels a little bit like we have already so much on our desk in order to,
Mhm.
like with the tools that we have, we already still need to explore so much that it's a little bit like somehow we try to keep a focus. Now at the same time, Alex, who co-directs the program, he's responsible for the technology and robotic department in the institute, and he's running a huge amount of projects that go within that realm. No, so we're in touch with many companies, not so much in the States. I think we'd like to, but mainly companies in Europe, mainly for kind of obvious reasons of maybe our difference. So we are but we're keeping an eye on what everybody is doing. Um, Yes, I think, but I want to underline again our very happy relationship with WASP. That I think also comes from this kind of common belief or this common desire to make a new architecture that is absolutely green, no? So hence working with Earth and not competing, but sharing and trying to progress, trying to push each other as much as possible until we reach solutions that are convincing for everyone.
Yeah, it seems obvious that a big part of that progression is only possible in a university setting where you can afford the human effort and the R&D because the students are getting a learning experience out of it. So it's
Yeah.
not like you're experimenting just to waste a bunch of concrete or waste a bunch of mud. You're gaining all this knowledge, and even if you destroy the building at the end of the day, you still have something of value.
Yeah, of course. Obviously, the market needs to be competitive. Companies that make house, it's a balance, right? And they cannot afford. I understand that many of them cannot afford to search as much as universities. I find it very nice when construction companies set up their cells and do R&D, and I think it's also absolutely necessary. But also universities are there for that, no? I think so. So for me, more than ever, these sort of partnerships make sense.
What they should do, if they had the money for it, is just give you guys a printer to work with and see what the problems are so that they can workshop it, fix it, and improve it. That way, when it goes to market and someone's paying for it, it's a reliable product.
Yeah, no, absolutely. And we, to a certain extent, we do that, and we are very open to doing it. Of course, absolutely. For us, maybe the thing I would like to say is that we like to when we discover something, we like to share it, right? So we are a little bit kind of, I think it's something maybe of our times where we're questioning a lot the patenting system, no? Because and 3D printing is an incredible example of this because this technology was around in the 70s and then was patented and no one could use it for 20 years, right? So it kind of stopped evolving. So we believe a lot in publishing. We believe a lot in, even if we don't publish enough, we have tons of articles that we are meant to publish, but that takes so much time and we have some delay in that. But we like to show, and I'm very happy for that to be on, on your podcast to explain what we do and to tell people that we are doing this so that if they want to know more, they can look at us on the internet or they can contact us, and we're very happy to share most of the work that we do. I think the more we are doing this, the more we will lead to good results that will make the construction industry better and better living.
Yeah, I like that part about sharing information a lot. I think it might be what scares the companies a little bit because if they give you the
Yeah,
printer and they dedicate all the resources, then they want some secrets. So I'm
absolutely.
sure you're able to keep some secrets for their IP in those circumstances. Uh,
Correct.
yeah,
Yeah, yeah,
so
of
that way,
course. Of course, we in that sense we operate within a very different reality from a company. I like to think or to believe that there's going to be work for everyone because I think that there is such a huge market that is going to open to that I think everybody who does it well will do a lot. I'm maybe it's wishful thinking, but I I tend to think that there's not going to be one big company that is going to do everything. I think different
I think
companies are
that's
going to be able
logical.
to coexist. Uh,
I think that's very logical, especially if you look at construction as a whole is a very decentralized industry. And then also
yeah,
historically, when technologies replace human labor, you don't end up with a bunch of unemployment. You end up with a bunch of new jobs that are usually better.
absolutely. Absolutely, the knowledge, the way to work through this. I can tell you from a design point of view that the design for this is more difficult than it is for other construction techniques. Therefore, it requires more work. And as you said before, it's work that is not physical labor. It's work that is intellectual work and design work, engineering work. So it's work that is absolutely done by a human. I don't believe that the algorithm will ever do everything. Absolutely not. I think things will remain incredibly human. But yes, there will be less tough labor on the construction site. That for me is the way to think about that. I don't think we should be afraid of that. I know many people are, and I understand their concern. But I think there is a transformation of knowledge and a transformation of professions, no? And I think it's important to acknowledge that because it also helps us to move on. But we have to stay
Yeah,
critical. Absolutely.
always, always.
Yeah.
So right now for IAAC, is there anything that can help IAAC out, or maybe if a student wants to apply, where could they apply, or if a company wants to reach out and work with you, what's the best way to do that?
Sure. So we are super porous and very open to discuss. So can definitely, I mean, if a student wants to apply, the first thing is they can go on the website. They can go on Instagram where we publish everything. So that's a very easy thing. 3DPA and IAAC, you can find us like that. And then afterwards, you can also go to our webpage, which is also 3DPA IAAC. It's very easy to access, and there is not only we have a blog where we have again all the content, but then there's also the practical information about the program, the dates, the fees, and the learning outcomes, etc. And we love we yeah, of course, for us it's super good to have students, no? Because we are, I mean, I think there's a huge need, and I think it's also a very nice format to work. So the academic program has been a lot of fun. So please do join us. And we have had always a few students from the States. I think we're always looking forward to have more. We have our students come from all over the world, so it's really fun in that sense. Um, and then when it comes to companies, we are also very open for collaborations on all levels. Whether it's clients that wish to go into a 3D printing with project with us, we have a few of these going on at the moment, and we're definitely happy to do more. and also companies that develop technology and want to test it out, or want us, to do some exploration, some prototyping, some design exploration. I think that's also something that we are extremely interested to. Absolutely.
And is there anywhere on social media you post pictures, videos?
Yeah, Instagram very intensively actually. We like the
Yeah, I follow you
format.
guys.
It's a
It's great.
format to stay in touch. So yeah, you can definitely follow us there.
And the 3D printed account, it's at, what's the at?
I will tell you now. It's IAAC underscore 3DPA. P for printing, A for architecture.
Yeah, cool. That's probably the best place just to quickly see all the
Yeah.
short-term attention span videos.
Exactly. No, it's a very, yeah, it's a huge collection of things, and it also says what are the professional projects we're working on. It keeps also a kind of almost a daily update on how the group is doing.
Yeah, I bet it's pretty cool for the students too when their work that they're so proud of gets featured on the page, picked to
Yeah,
uh
absolutely. And I can tell you something now. So our program ended up in February, and then a month later we got an important job for an installation at the Venice Architecture Biennale, which for architecture is the top event in the world, right? It's the most important one, and we worked with six of the students that had recently graduated in order to do that project. And we did this for a couple of months. We just inaugurated last weekend.
congrats.
So that, thanks a lot. But I can tell you that this, as a student, I would never have had this chance, no? And I think this is, of course, related to this being such a new technology, creating so much interest, that suddenly the students that come out, they have these chances by now. And I think that this is very, very beautiful, obviously.
Yeah, absolutely. When you were mentioning you guys are so busy with the 3D printing, that was very relatable to me. I would love to cover more types of robotics and all kinds of finishing robots and stuff, but there's so much out there and there's only so much time in the day. But
And in one life. Right.
yeah, yeah, but it is really fascinating. It's great that you guys are open and sharing. Is that a quality that most universities have, or is that unique for IAAC?
Maybe not most. I think we are quite special in university because we are very young, and because it's a young school. Most of our directors are young, the staff is young. It's also the school is also a foundation, so we are not a huge university department or a department of a huge polytechnic university. We are related to the polytechnic university, but let's say we are very agile, no? Which means that we can move very easily, we can adapt very easily, we can embrace change very quickly. And I think that and we have embraced the open source world, right? We have really surfed on that and worked with that. Therefore, and we have also studied this question of the patent, and we realized for us the patent is not such a good model. In our case, maybe we would make a little bit of money like that, but the sharing dynamic is much more useful. And our students, I told you, they're from all over the world. IAAC has well, it changes every year, it grows every year, but at this moment we have a number of students of approximately 200 per year, 200, 250. So these are all people that after a few years, they end up all over the world, and we have a really cool network of people that are all over the place doing things. And so, Alex now is going to Honduras, where some IAC alumni have set up a robotic factory. Um, um, well, I'm not going to get into it because there's many places where we go because we have some very strong roots actually.
What
So
are
join
the,
us.
when you say rules, what do those mean?
Roots?
Oh, roots, very strong roots. I thought you said
Yes,
rules,
yes.
rules.
No, no, sorry, I meant roots. And they are not really
All good.
roots, but let's say they are connections or friends or alumni or mainly friends. I think all of our alumni are friends.
Yeah, I think it's really advantageous, like you said, being a young university, being able to make rapid changes, create departments around industries that are young. and attract a bunch of attention. I mean, the 250 students, I didn't realize that's a really tight-knit community. And so the
Yeah.
to have two departments for is it all architecture, all 250?
So we have, I think, approximately 10 master's degrees. There is
Okay.
one of them is a design master's degree, another is urbanism, and in between there is construction with timber, there's 3D printing, there is robotic construction, there is a more generic architectural master's degree. So we are targeting this scale, let's say, between design construction and urbanism. No? So, for example, in the 3D printing program, we have 20 students. So that's 10 or even a little bit less percent of the total amount of students we
Okay.
have.
Yeah, cool. Is there something else that we haven't discussed that should be discussed?
Um, yeah, maybe there's one, and I don't know where it fits. I don't know if at the end but um, so this morning we gave a talk with Alex in the construction fair here. Um, there were actually a lot of people. It was very nice. Uh, so some sometimes I like to you know because people always ask me what are the benefits of 3D printing, no? And and one of the reasons we started this project is because we like to question the standardization in which construction goes. No, we like as architects we like to think that your house needs to be different from my house because you are different from me because you might have a different family or because you have different habits, but also because you live in a different geography than mine. That means that your access to resources is different than my access to resources. It means that the climate around your house is different from the climate around your house. So because of the difference in resource, different climate, the difference in social structure, we like to think that architecture should not be the same everywhere, but a building in your geography absolutely needs to be different from a building in our geography. So
Hmm.
we really, so 3D printing is definitely interesting because it's a technique that will enable to construct, more optimized, faster, less material, automated construction. We believe in that, absolutely. But we believe that these are the, let's say, the advantages that are driving the construction industry. We are architects, right? And we need, of course, to collaborate there. But so I like to think that the potential goes beyond that. Not only these ones I just mentioned of the optimization, but also the fact that we can custom make solution, no? And we can custom make solution, for example, on the scale of the detail, no? Like do a corner in one way or another. We can customize or be flexible in the design when it comes to climatic performance. Therefore, the east wall can be different from the south wall because they have different climatic necessities. We like to think that we can change the design according to structure, to make a wall that becomes thicker because it needs to receive a beam, or other strategies like that. And then eventually we like to think that this freedom or flexibility that we have as architects can enable us to work with different floor plans and to work with different house organizations or architecture because you have a different way of living than I have a different way of living. No? So for me, it's interesting to cultivate the fact that this technology, because it is a digital technology, invites to working as an architect away from hyper-formalized or standardized ways of constructing economy of scale, and to be able to create architectural solutions that are adapted to the need of every individual, potentially.
Yeah, I like that idea a lot, especially, I mean, it gives people control over their living spaces, and the customization is really an awesome thing. Uh, I
Yeah,
think it's something people in America really appreciate. In addition to like Belgium, people want to have their own home.
yeah.
There's like a historical American dream around home ownership, and I think these days a lot of people want to move everyone towards cities, but uh, it's beautiful to still see technology going towards the independence as well.
For me, it's crazy to understand that, and it's beautiful that digital technologies are enabling us to step a little bit out of kind of custom of a Fordian, like mass production, make 10,000 times the same part. No, now with the robot, we can make 10,000 parts that are all different one from another for the same economy, and
Mhm.
that I think is extremely interesting. And I think the world definitely lacks that, no, because at the moment, it's the way that a flat gets built in China is the same as the way that a flat gets built in Belgium or in Argentina, no, and I think this makes zero sense in a way. And so I think it's great to think that robots, are reopening the door to craft, to different ways to work with materials, whether it's earth, cellulose, or timber, or concrete, or all of the ones that they are, and call back all of these hand crafts that used to exist and that are by now are kind of becoming too expensive, and therefore the market is not cultivating them. I like that digital technology is waking this up and putting it back, back on the map to say, yes, our house again can be something else. It doesn't need to come out from a factory that is producing 100 times the same house every day.
As an architect, do you believe that a building has a soul?
That's a good question. I can tell you that it's architecture is great because it can be evaluated on so many levels, right? So when you go in a good building, you can when you see a good building, you can write many books about it. It's not something that can be discussed in 10 minutes. Architecture can be discussed over a lot of time, even just a single building. Um, I think in that sense it has a soul, absolutely. I mean, I think it's a complex discipline, and there are many bad buildings and also many good ones, and it's very difficult to say what makes a good building. No, I think good building is something in which some people have definitely put a lot of heart, and that's maybe when this soul, no, goes from the people that make to the actual physical thing.
Yeah, that's why I asked, because I'm curious where that soul stops and ends. So
Yeah.
if you have a prefab building with 1,000 units made of precast concrete, they just take the formwork apart every time, pour it in, pour it in, pour it in. Uh, does that have a soul?
Yeah, absolutely. No, I think.
Oh, it does.
Ah, no, sorry, you got cut with the last bit of your question. So I can you say it
Does
again?
that have a soul? Does that still have a soul?
Good question. I mean, there is, well, I think of course we have to also value that to a certain extent because there is house shortage, and I think if we are able to produce very affordable houses like that, I think it's definitely something that we should not look down on. But I think we definitely have to think about how to improve things, no? And I think that this sort of model can definitely be improved, and it doesn't have to be improved at the expense of its economy. I think that's where 3D printing is interesting. Is I think we can improve things and still enable to make affordable housing. I think it's very important because the world needs that.
Yeah, I think you can. It's a fair thing to say that it's important the world needs it and it doesn't have a soul, potentially.
Yeah, yeah,
But
absolutely. Why
I don't
not?
want to put words in your mouth. Um,
No.
so if it's that's important, the world needs it, and it doesn't have a soul, we agree?
Yeah, why not? Why not? Let's say, you
Okay,
know what
so
we can
now,
say? We can say it doesn't have a soul until someone starts to inhabit it. Then, when someone
okay,
inhabits a place, there is definitely something beautiful that happens. So the soul
that
starts
makes my
to
next questions
happen then.
much
Go ahead.
simpler. You just answered the next two as well. So the next one was going to be now you have the robot and it's an architect's making a custom home for each of the 1,000 people. I imagine you would say that has a soul. Uh, it's being designed by person and inhabited by person. And then the final one would be the robot sets off on its own to create 1,000 homes based on data from 1,000 people from their cell phones or whatever, the most
Yeah.
ideal home, for their lifestyle, their climate, their conditions, everything you mentioned. Does that have a soul?
Yeah, I think that this question I think is very good, and I think it's great that you ask them. Of course, they're really difficult to answer. Um, what I think while you're speaking is that for me, one of the most important things in architecture is that it's for the people, right? and the stronger the disconnection between the way that a house gets made and the way that it is inhabited is problematic. So I think that if the person can manage to, to collaborate within the design and the making of the house, and I'm not meaning that the person needs to do, the work there. But if a person can decide what kind of house they want to live in, I think it will definitely produce a better architecture and therefore better buildings. And I think that AI will help to do that, absolutely. And I think also that participatory construction, which is quite present at the moment, is also something that will help a lot. And I think also a very good dialogue between the architect and the user is absolutely important. No, the architect, I think we are at the moment very critical in architecture about architects that have been developing buildings without clients or with listening very little to their clients. And we've been without questioning what a star architect is. And I think at the moment the user needs to have the voice, no, to be able to make sure that the house that they inhabit is really caters for their needs, no, way beyond what the building looks like, actually how the building works and how does one inhabit the building. And as you said, no, interesting to think how does new technology, AI, robotic construction can help to get there, no? Because it could also go wrong, of course, no? We could go into a dystopic way of thinking about this, where the user loses more and more and more. Like one huge company gets all of the market and has no employees, and everything gets robotically produced, robotically designed, robotically produced. The data of the people are being sucked without them even knowing it. And then suddenly, okay, yeah, you move here, you move there, that's your house. And of course, that is something that is absolutely questionable. So there is definitely wrong ways, I believe, in which this could go. I think it requires a lot of maturity. It requires a lot of people to work on that from a technical point of view, but also from a philosophical point of view, and from a sociological point of view. From many different perspectives, this needs to be addressed to make sure that we move to solutions that eventually serve the user, serve the population, serve the people, rather than serve the interest of very few, like it's often the case.
Yeah, it's an interesting dynamic because the mission of getting towards automation makes it easier for one central organization to have that level of control. When everything's automated, people don't individually need to learn how to hunt the rabbit and make the glue anymore. There's a corporation that makes glue for you.
Correct. But I think that's where there is a sharing economy that can really work. No, I think that's where sharing knowledge, and I think that, like, somehow questioning the patent system and to say rather
You just
when I
don't want to
find
lose
something
it.
that, Hmm, yeah, you don't want to
You don't.
use this knowledge. Absolutely.
And like with AI, you get so dependent on having something done for you that less people will be inclined to learn themselves and seek new knowledge. Like you've dedicated your life to seeking new knowledge. I like to think I'm dedicating my life to seeking new knowledge. And I don't know how many people are still going to do that when seemingly all the world's collective knowledge is available. But I guess people might have said the same thing with Google.
Yeah, it could be. And I think you're right. It's a danger. And I think that we have to be demanding, no, towards ourselves. We have to fight for what we want. We have to be passionate about what we do. And I think if we have that energy, then we will question models that providing things that we don't want, no, or that are not directly good for us. I think we have to remain definitely critical and continue to live and to work with passion. I think that's important.
Yeah. Well, it's a fun time to be alive.
Absolutely. Absolutely more fun than ever. Absolutely. The time of big changes, but incredibly stimulating changes and times, no? Absolutely.
Absolutely. Cool, man. Well, it's been a really fun conversation, and you've brightened up my vision of universities a little bit. I really appreciate that you guys are doing hands-on learning stuff, and people complain that architects design stuff like they've never been in the field before. So having students actually
Mhm.
go in the field, work on buildings, with the methods that hopefully they'll be using in the future is like the best experience they could get.
Yeah, absolutely. I think few universities maybe can afford to do that. I mean, I think there's more and more, but I think it's a key. Absolutely. Architecture design. I think is a super important topic, and if it's informed with you know, with how to actually build, it can only be better. It's a chance also that we have. I can understand that not all of the universities have this chance, no? I think so. But I'm happy that it's a brightened your day. That's very good news.
Yeah, absolutely. And the number of projects is increasing, number of students increasing, hopefully, and we'll see tremendous progress. And hopefully we can do this again in maybe 6 months or a year and talk about all the updates.
Absolutely. Absolutely. Well, I'm sure we'll have updates by then. So it would be great to catch up again soon.
All
Absolutely.
right, man. Thanks for
And you
joining
have
me.
to let us know when you come through Europe, because it would be great to have you here. So keep us posted about your trips.
Will do.